Bismillahir Rahmanir Rahim. And I am starting my class. So let's recap a little quick. Who will tell me what were we doing in the last class? So in the last class, I gave chance to different students to come forward and solve questions, and so you guys solved questions individually, and that was really fun, and you guys did a fabulous job. So and then we talked about isotopes, I remember, in our last chemistry class. So I told you how to calculate the relative atomic mass, the average atomic mass, remember, keeping in mind the number of isotopes and how they exist in nature. And then I wanted you to do this question number 6 at the end of chapter 3. Okay, and I will not be repeating anything that I have covered in my last class, because otherwise I won't be able to progress forward. And so I have recordings of my previous class on my channel, so please go ahead. You are most welcome to go and visit and listen to my previous classes recording for those of you who were not there in my last class. Okay, so let's move on and let's progress. This is question number 6. Okay, this is the end of chapter 3. And so let me read this question. And I have copied this question real big. Okay, I want to discuss with you guys. So this will tell me how much have you revised from the previous class. So let's talk about hydrogen. Atomic number is 1, has 3 isotopes. Okay, and the 3 isotopes can be written as this, right? And we discussed that, we use symbols rather than the whole name because it's easier. So H is the symbol for hydrogen, and then what are these numbers and what are isotopes? So who is gonna volunteer to answer this question? What are these symbols and why do we have these different numbers? Yes. And if the element is the same, because the symbol is the same, then why are the numbers different? Okay, Iman Javed. Yes, Iman Javed. I'm trying to unmute you.
Yes, teacher.
Yes. So can you tell me why are the numbers different and what are the numbers representing and what are isotopes?
These are the numbers are different because this is an isotope, and an isotope is which has the number of protons same but the number of neutrons different.
Okay, so what are these numbers and why are they different? Please explain a little bit. No? Okay. Okay, Javeria Fatima, Okay. Furqan Azhar. Yeah, Iman Javed, your answer is correct, but I want somebody to please explain a little more in detail. Yeah, okay, Sidra, you go ahead and explain us. Can you please? Yes.
The number at the bottom is the atomic number and the number on top is the atomic mass.
Right.
So the first one, both of the atomic number as well as the atomic mass both show 1. So that means that the proton number is also 1, and this is the mass. That means there are no neutrons, only 1 proton.
Right.
Over here, there is 1 proton, and here there's 1 proton and 1 neutron.
Right.
Here there's 1 proton and 2 neutrons.
Right. So they differ in their
Neutron
number of neutrons in the nucleus. And the number of proton is the same because their atomic number is the same. And that means they are the same elements, right? So this one has no neutron, this one has 1 neutron, and this one has 2 neutrons. I cannot do that. I just cannot do that. Okay. Okay, what is the difference between the three isotopes? Okay, this we have already done. Now, hydrogen reacts with chlorine in sunlight, forming hydrogen chloride. Would you expect the same reaction for each isotope of hydrogen? Why? Yes. Please use the chat window. You can use the chat window to answer the isotopes. Okay. So will all the isotopes react the same way? Would you expect the same reaction for, because the neutrons are different, so they would not react the same way? So Shaima is saying, no, they will not react the same way. Wajiha is saying, no, Wajiha, I'm going to unmute you. Where are you? Raise your hand. Okay, Wajiha, I've unmuted you. Can you please explain your answer? Why are you saying that they would not react the same way? Wajiha?
Hello.
Yes, Wajiha. So you said no, the isotopes won't react the same way. Why?
Hello.
Okay, you know what? We are running out of time, so that's the thing. Momina, you are not in grade 6, so let me ask somebody who is in grade 6. Okay, Javeria Fatma. Yes, Javeria? Yes.
The reaction will be same because the electrons are included in the reaction, not the protons or the neutrons which are in the nucleus. The
Very
nucleus is
good.
not
Right.
the nucleus is not included in the reactions.
Okay. And so, complete your answer. Yes, it is correct. Please complete your answer. See, in IGCSE, the thing is, you might know everything, but the way you answer, the way you satisfy the question is important. Do you know that the only difference between A grade and B grade is that the A grader explained himself better than B? The level of knowledge might be the same of A grader and B grader. The only difference lies in how you are satisfying the question. So you might be, answering correctly, but you have to satisfy the question. So the way I would like to see this answer would be this, that since it is the electrons which participate in reactions, since it is the electrons that participate in the reactions, the nucleus does not participate in chemical reactions. Remember this. Nucleus does not participate in chemical reactions, and they differ in their nuclei. They differ in their nuclei. Why? Because they differ in their number of neutrons. Neutrons are found in the nucleus. Their number of electrons is the same. All the three isotopes have exactly the same number of exactly the same number of electrons, which is one proton, one electron. So because the number of electrons is the same of all the isotopes, they are going to react the same way. Okay, can you hold this camera for me? Okay, so that is why the reaction would be the same of all the isotopes, because it is the electrons which is participating and the number of electrons is the same in each isotope. Also, kindly, when you are answering a question, don't just give me the correct answer. I want you to explain your correct answer. I want to know if you really understood. Okay, and also I want your other class fellows to understand from you. Okay, so whenever you try to answer a question, give me the correct answer and then explain it. Why is your answer correct, or why do you think that your answer is correct? Okay. Part D, chlorine exists naturally as two isotopes. 75% is this isotope of chlorine with atomic mass of 35, and 25% is chlorine 37. So what this means is that out of 100 random chlorine atoms that you might have taken from nature, out of 100 random atoms of chlorine that you have taken from nature, 75 of them have the mass 35. 75 of those chlorine atoms have 35 mass, and 25 of them have mass 37. So now, why is the relative atomic mass of chlorine 35.5 in your periodic table? Okay, so definitely this is the average atomic mass. And so you have to calculate the average atomic mass for this chlorine to show that it ends up as 35.5. So who can do this calculation? Who can do this calculation? And not only do the calculation, but explain to your friends, explain to your, class fellows. Who can do that? Let me do it for now. Let me do it because, yeah, okay, let me do it, okay? Because, you will need to share your screen and everything. So let me just do it. Okay, so the information that the question gave us is that, you may make sure, can you please just stand up and then make sure that what I'm writing is showing in the camera. So 75% is this isotope, chlorine. I will write mass at the top and the atomic number at the bottom, and 25% is, so by the way, I explained this in my last class, but I'm, for those of you who did not attend, you can benefit from this question that I am repeating, okay? So this is the information given in the question, okay? 75% is this. Now, what is this? Like out of 100 chlorine atoms that I took randomly from nature, okay? So my total number of atoms is, because, we are dealing with percentages. A percentage is a ratio. That means out of 100. So let's say the total number of atoms, because I'm dealing with ratio here, so my total number of atoms would be 100, okay? Out of 100, out of these 100 chlorine atoms that I took randomly from nature, 75 of them had mass 35, and 25 of them had mass of, and this is mass, okay, atomic mass, 35, and this is 75 is 35, 25 is 37. Okay, how do I calculate the average? How do you calculate average for anything? How do you calculate the average? For example, what is the average marks that this class got? So what does the teacher do? She adds the marks that each student got and then divides the sum by the total number of students, right? Isn't that correct? So I would use the same method here to calculate the average atomic mass, and so the sum of all the atomic masses, or you can say the sum of the mass of all the atoms, sum of mass of all atoms, okay, divided by the total number of atoms. Right, now let's see, 75 of them had 35. So what is the total mass of this isotope? If I say 10 of them have a mass of 2, for example, if I say 10 of them have a mass of 2, the total mass would be 10 multiplied by 2, right? Because I am adding 75 35 times. So to get sum, I will just multiply 75 by 35. And so that would be the total mass of this isotope, okay? Now, if I want to know, what is the connection? Okay, yeah, good. Okay, so if I want to know the total mass of this isotope, I will simply multiply the number of this isotope with its mass, because that would give me the total mass of 37 chlorine isotope, okay? Now, when I solve, I mean, this is the sum, right? This is the sum of all the 100 atoms mass. This is the sum of the atomic mass of all the 100 atoms. Now I will divide that by the total number of atoms. So my total number of atoms is 100. Okay, so 75 multiplied by 35 is 2625. You can use the calculator if you want. And 25 multiplied by 37 is 925 divided by 100, and the sum of 2625 plus 925 is 3550 divided by 100 and that gives me 35.5. Because I have 2 zeros in the denominator, the decimal place would jump 2 places back. And so I will have 35.5 as my average atomic mass for chlorine. Average atomic mass of chlorine. Okay, so this is how I got it. Okay, so is there any question regarding this? You can use the chat window. Okay, okay. So if there's any question, please let me know. For those of you who are joining for the first time, please refer to my previous classes, okay? Jazakallah khairan. Okay, then the next part of the question, which is, okay, we will do this later when we will talk about the relative formula mass. Okay, let's talk about the relative formula mass. What do we understand by relative formula mass? Now, the reason why are we calling it relative? Relative means, what does relative means? What does relative mean? In relation to something, right? In relation to something, compared to something. Now, the reason why we are using relative with formula mass is because formula mass is the sum of the relative atomic mass. Because remember, the mass of each atom is compared to carbon 12, 1/12 of the mass of carbon 12 isotope, right? So because we are using relative atomic mass, their sum is going to give us formula mass. So therefore, formula mass will also be called relative. Now, what is formula? What is formula? And this also we discussed in our last classes. Formula is just a shorthand writing. It is a short cut, you know, like a shorthand writing, which tells us about the number of each type of element in a substance using their symbols, okay? And symbols are given in the periodic table. I mean, the more you use them, you will end up learning them, but don't ratify them. I mean, as you will, you know, study chemistry, you will end up learning them. So now tell me, what is the difference between this and this? Now here, I wrote this symbol O for oxygen, and then a small 2, and then a small 2 on the right lower corner, right? This is called a subscript. A subscript is, you know, a small number that I write on the right lower corner. What does this represent? And then why have I written 2 in a different way here, next to the symbol this way? What is the difference between the two? Very good, Muhammad Sharik. Good job. Yes. Now, this question was primarily for those students who have recently joined grade 6, right? So if you were not in grade 6 and you were from grade 7 or 8, then, you know, yeah. So this means that there are 2 atoms within one molecule, and this means 2 different atoms together. Now, what do I mean by that? For example, this is an atom of oxygen. This is an atom of oxygen, okay, simple. 2 oxygen atoms, this and this, separately. This is one oxygen atom. This is one oxygen atom, and this is another oxygen atom. So total we have 3. We have 2 different oxygen atoms. Now, if they join together physically, okay, if they join together physically this way, if they join together physically this way, and they will not separate, but they will exist as one particle. They will exist as one particle, okay? This is called a molecule, okay? And 2 atoms have physically joined together to now behave as one. So this is one hydrogen gas molecule. These are 2 different hydrogen atoms. So yeah, I have taken 2 examples, 1 oxygen and 2 hydrogen. So this, again, same thing for hydrogen as well. This is one molecule of hydrogen, 2 atoms joined together, and these are 2 different hydrogen atoms. So the reason I'm talking about this in detail is because I want you to understand the difference between these 2 numbers. They might be the same numbers, same symbols, but the way they are written changes the meaning completely, right? This is one molecule. These are two different atoms. So whenever you see a big number on the left-hand side next to the symbol, on the left-hand side of the symbol, that means this is giving you the number of particles. This number that is written on the left-hand side of the symbol tells you the number of particles, individual particles. Whereas the small number that you see on the right lower corner as a subscript, that tells you the number of atoms in a molecule, or you can say the number of atoms in one particle. Within a particle, it tells you the number of different types of atoms in one particle. And this gives you the number of those particles. Do you understand? So what do you mean by this? If I write this, what does this mean? What does this mean? Yes, Sidra, tell me, what does this mean? Can you draw them? Can you draw them using this marker? Go ahead. This means what? Come on. This means I have two of these molecules. Two of these molecules. So, yeah, okay, go ahead. Okay, even if you're wrong, it's okay. Very good. Okay, so now explain.
So these are two hydrogen
Atoms. Because they are not physically joined, so they are atoms. No, beta, no. It's not like this, okay? So what we are trying to say is that two hydrogen molecules, okay? So one hydrogen molecule is probably this way, okay? So they're like physically joined together, and now there are two of them. So there are two of them, okay? So there are two of them. So they are joined together, okay? So forget this. So I have, this is one molecule, this is another molecule. So I have two hydrogen molecules. And if somebody asks me, how many hydrogen atoms in total do you have? How many hydrogen atoms in total do I have? So 1, 2, 3, 4. In two molecules, we have 4 hydrogen atoms. Okay, in two molecules, we have 4 hydrogen atoms. This is what I mean. Okay, now if I wanna calculate the mass of this one molecule, what should I do? If I wanna calculate the mass of this, what should I do? Tell me, Sidra. If I know the atomic mass of one atom, can I calculate the mass of the whole molecule? Yes, I can. Okay, and how will I do that? How will I do that? Let's talk about it. Okay, yes. So I know that one hydrogen atom is 1 atomic mass unit, right? So now one molecule has 2 of them. Okay, so this has 1 atomic mass unit. This has mass of 1 atomic mass unit. The whole molecule's mass would be 1 atomic mass unit plus 1 atomic mass unit. 1 plus 1 is 2. So 2 atomic mass unit will be the relative formula mass of hydrogen. Simple. So the relative formula mass for hydrogen would be 2 atomic mass units. Simple. Okay, let's do oxygen. Let's do oxygen. Simple. So oxygen again has 2 oxygen atoms bonded together, right? So the atomic mass of one atom is, what is the atomic mass of one oxygen atom? Use your periodic tables. 8. Yes, Amra Javed, 8. And then this is also 8, right? Because this is also oxygen. So 8 plus 8. That would give me the formula mass for the whole molecule. So 8 plus 8 is 16, right? So the relative formula mass for oxygen for oxygen molecule is 16. AMU, if you are, you know, like you don't even have to write AMU because this is relative, and relative quantities do not have units. Okay, so you can just write 16. Okay. Okay, now, so this is done. So I will give you questions. Okay, those students who are interested in solving questions, let me know through the, let me know privately. I have a few questions that I want you guys to solve. Okay, and I am skipping the balancing of equations for now, because I want you to know a little bit about periodic table and ionic and covalent bonding before we can start balancing equations. And then we will spend a lot of time on balancing equations. Okay, so with this, I have concluded the atomic structure, basic concepts of atomic structure. Contact me for the questions. I have only, okay, I have 1, 2, 3, 4, 5, 6, 7 questions. Okay, I have only 7 questions, so I will give chance to only 7 students. Whoever is interested, please contact me. Okay, so now I want to move on. This is easy, you know, calculating relative formula mass is easy. Now I want to introduce periodic table. I want to introduce periodic table. So let's start talking about the periodic table. I talked a little bit about it in my first 2 classes, I remember, but let's do a recap. It's okay. Okay, yeah, do not, I don't save this chat. I don't save this chat, so contact me privately through WhatsApp, okay? This chat is not saved with me, okay? So let's recap about what we discussed about periodic table, okay? So periodic table is an organized way of scientists of arranging all these elements that exist in nature, okay? So they have arranged them in a sequence so that it is easier for us to understand them and their characteristics and everything. So we will try to understand the sequencing of these elements according to their atomic structure, okay? According to their atomic structure. So I got this, but if it's not clear, I'll share my screen and I'll show you a better periodic table, which is according to the atomic structure, this. Okay, I hope you guys can see it. So if you remember, the number of group was representing the number of electrons in the outermost shell, okay? And the number of period is representing the number of shells, right? So, okay. So the number of group is representing the number of electrons in the outermost shell, and the number of periods is representing the number of shells. Please keep that in mind, okay? Remember it. This is very important. It will help you in the future in understanding a lot of stuff. Okay, so group 1, that means 1 electron in its outermost shell. And we drew these electron structures, if you remember, in our previous classes. We drew these atomic structures. So group 1, as you can appreciate, look at group 1. I'm enlarging it. Look at the fact, because I cannot annotate the screen. So so you can see that in group 1, all the atoms have only 1 electron in their outermost shell. Remember, the innermost shell can hold only 2 electrons. The second shell can hold 8 electrons, and third shell can hold 8 electrons, right? And then we are dealing with till third shell, okay? Because things get trickier from 4th shell onwards, and so you will deal with them in A levels, okay? So till O levels, we will deal with 3rd shell. Okay, so what are these shells? These shells are energy levels, right? Energy level meaning, if you have attended my previous classes, I mentioned that the electrons in the innermost shell have the lowermost energy, have the least energy. And then you can think of electrons as the kids of a mother and think of nucleus as the mother, right? So children want to stay close to the mother, right? And so the youngest the kids are, The youngest the kids are, the more they cling to the mother, right? And the older they grow, the more independent they get, and so they can take care of themselves and they don't cling as much to the mother. So in the same way, these electrons in the innermost shell, think of them as like, you know, real infants. So they cling close to the mother and they have the least energy. And so they have the least energy, so they cannot resist the attraction, the electrostatic attraction by the positively charged protons in the nucleus. And then we move on to the second shell. The second shell electrons have relatively more energy. They have comparatively more energy, and so they can resist that electrostatic pull from the positively charged protons in the nucleus. But that's an energy level. So that level is higher. So electrons that have higher energy are in the second shell. And so that shell can hold up to maximum 8 electrons, okay? And then you have the third shells. And of course, third shells has more energy. Electrons in the third shell have even more energy than the second shell electrons, and so on and so forth, right? So group 1 has 1 electrons in its outermost shell. Can you see that? Group 2 has 2 electrons in the outermost shell. Can you see that? Also appreciate the fact that period 1, now what is period? The horizontal rows. The horizontal rows. Group is the vertical column, right? Group is the vertical column. I hope you understand the words that I'm using. So group is the vertical column. Period is the horizontal row, okay? So period represents, the number of period represents the number of shells the atoms have. So can you appreciate that period 1 starts from hydrogen. Period 1 starts with hydrogen. So you can see that period 1, atom has only 1 shell. Period 2 has 2 shells. Period 3 has 3 shells. Period 4 has 4 shells. Okay, I hope you appreciate that. So group 1, outermost electron is 1. Group 2, outermost electrons are 2. Group 3, outermost electrons are 3. And by the way, this periodic table has omitted that block of transition metals. I will show you in the other. So, you know, to simplify things up for you so that you don't get confused. So just focus on what point I'm trying to make. So third group has 3 electrons in its outermost shell. Fourth group has 4 electrons in its outermost shell. Fifth group has 5 electrons in its outermost shell. 6 has 6, and 7 has 7. And 8 has 8 electrons in its outermost shell. And we know that the second shell can have maximum 8 electrons. You cannot have more than 8. Okay, so in order to be stable, in order for an atom to be stable, it has to have 8 electrons in its outermost shell. And of all these atoms that we are looking at right now in the screen, you can see that only group 0 has 8 electrons in its outermost shell. Okay, the rest of them have less than 8. So now the rest of them want to be stable. So they react in such a way, they participate in chemical reactions in such a way so as to get that 8 electrons in their outermost shell. Okay, so this is important to understand because you will then understand why they behave the way they behave in chemical reactions. Okay, because they're trying to get that 8, the stable number of 8 electrons in their outermost shell. Okay, noble gases. Now, noble gases is a term which is given to group 8 elements. Group 8, helium, neon, and argon. Helium, neon, and argon. They are happy. They don't want to change anything. Okay, unlike others. Others are trying to change because they want to get 8 electrons in their outermost shell. Okay, now once I have made that point clear, okay, I don't check my chat window while I take my classes, okay? So I'm receiving a lot of WhatsApp messages right now. I am sorry, I will not be able to check them right now. Okay, so once you have understood that, let me introduce the periodic table. Okay, let me introduce the periodic table to you. So we have already appreciated that group 1 are those elements which have only 1 electron in its outermost shell. So How can it get stable? How can the group 1 elements get stable? They have only one. They can either gain 7 electrons, they can either gain 7 electrons, or they can give away 1. Remember, I used this. Can I get, I made a, no, not this. I made a better one. Okay, let me use this. Okay, so this is group 1, right? The atomic number is 11. So how will they arrange? 2 electrons will take the inner shell, okay, and then 8 in the outermost. So 8, I'll make 8. So 8, 9, 10, and then 1 is left. That will be in the outermost shell. So it has only 1 electron in its outermost shell. Now, how will it get stable? It will get stable by either gaining 7 more and then, having 8 in its outermost shell, or by just giving this away 1. Now, as I, use that analogy that I just used, think of nucleus as the mother and these children. Now, who can give 7 children? Who can give 7 children? I mean, it's difficult, right? That will require a lot of energy. So no, they're not going to get 7 electrons. So it's easier for them to lose this 1 electron. And by losing this 1 electron, what happens? When they lose the 1 electron that they have, is that what happens is that they have now only 2 shells left. They have only 2 shells left. And so this is the structure of a sodium ion. Now what is that? Because how many protons does this atom? Now this has lost the outermost. It has lost the outermost electron. Now how many protons? Protons is the same, unchanged, which is 11. But electron is, the number of electrons is now 10. Right? So protons are positively charged, electrons are negatively charged. So they are 11 positively charged electrons, but only 10 negatively charged. So you have an overall positive 1 charge on sodium. Okay, because they lost the outermost electron. So they have positive 1 charge. So remember, group 1 elements always have positive 1 charge, because in order to gain stability, they lose the outermost electron, and therefore it is a charged particle. An ion is charged particle. Ion is a charged particle. Okay, now let's move on to group 2. What happens in group 2? Now group 2 meaning that this has 2 electrons in its outermost shell. Okay, so it will lose the, it can either gain 6 more electrons, or it can let go of 2 electrons. So letting go of 2 electrons is easier. That will require less energy. So they give away their 2 electrons. And by the way, the rest of the electrons will stay where they are. Okay, you can draw them. I'm not drawing them because of, lack of time, but you can draw them. Okay. And so the number of protons stays the same, which is 12. So protons are positively charged. So I have plus 12. But then how many electrons are left? Only 10. Again, 10. Okay, this third shell, these shells are nothing. They're not structures. Okay, don't think that, there are circles in the atom. No. These are just the paths, the orbit, the paths that the electrons take. So when the electrons go away, there is no path left. There is nobody to rotate, right? So no orbit, no nothing, no path, right? Like in solar system, you make the sun in the center and then planets all around. So what are those circles that you make? Those are not structures. Those are just pathways that planets take around the sun, right? Similarly here, you can think of these are the pathways or the orbits taken by the electrons. So when the electrons leave, there is no orbit, right? So I have 12 positively charged particles and 10 negatively charged particles. So the charge is plus 2, right? So that is why group 2 elements have positive 2 charge. And then again, similarly, group 3 will have +3 charge because it will have 3 electrons in the outermost shell. So either they can gain 5 or lose 3. So losing 3 is easier. And so +3 charge, okay? And then talk about the fourth group. Well, I have done this discussion before, but you know, just to recap. So this fourth one has to either gain 4 electrons and lose 4 electrons. So the energy required is the same. Energy required is the same, and therefore, you know, it's equally difficult to do either. So what they do is that they share. Okay, usually they share electrons because they cannot give, and nobody can give them because they require a large number of electrons. So therefore they share. Okay, mostly group 4 elements, they do not give away their electrons, but they share. Now, group 5. Okay, group 5 has 5 electrons like this. And so either they will gain 3 or lose all 5. Now, losing all 5 is more difficult. Gaining 3 more is easier. So can I get a different colored markers? So they get 3 electrons, and that makes their number of electrons 3 greater than protons, and so they acquire -3 charge in their ions, the charged particle, right? And I hope I'm making sense. And then this group 6 will acquire 2 more electrons, and therefore -2, and this halogen will acquire 1 extra electron, and it will get -1. And you can sit down, draw these atomic structures, and see how they are gaining and losing electrons to get their outermost shell stable, right? And then you will understand how they make these ions, okay? Okay, so after you have understood this, then let's move on. So the atoms that can give away electrons, they will form charged particles. Like how? So let's do this. So let's do this periodic table first. Okay, so group 1 can give away 1 electron, group 2 can give away 2 electrons, so +1 charge, +2 charge, right? Then these are transition elements. Okay, we will omit these transition elements for now. Don't confuse yourself. They have a variable number of electrons in their outermost shell. They have variable number of electrons in their outermost shell, right? Now, then we have this group 3, group 4, group 5, 6, 7, and then these are the noble gases. Okay. So remember, these are nonmetals. On the right side of the periodic table, you have nonmetals. And the substances that can give away electrons are called metals. You know, metals are shiny, hard substances that can conduct electricity. Okay, we will talk about them in detail later. And these nonmetals are simple. They are not charged. Why? Because they gain electrons. Okay, and so they share electrons. Now I will talk about why do they behave the way they behave. Now we have 2 types of bonds. Okay, ionic and covalent. Now, what do I mean by that? Ionic is when atoms can completely gain or lose electrons. When they can completely gain or lose electrons, they form ionic compounds. Ionic, the word ionic has come from ions. Okay, ion means charged particles. So basically particles that can have a charge, okay, by losing or gaining electrons make ionic compounds, or they make ionic bonds. Okay, are you understanding, Sidra? Okay, and atoms that cannot completely gain or lose, but in fact they have to gain, both of them have to gain, such as for example oxygen with oxygen. Okay, you know, the oxygen molecule is oxygen with oxygen. Now both of them want to gain electrons. How? Because oxygen has 6 electrons in its outermost shell. So both the atoms need 2 electrons. Both the atoms need 2 electrons to be stable, right? So none of them can give an electron. So we don't have an electron donor, okay? So we have, like, both of them want to gain. So what they will do is that they will share, okay? What they will do is that they will share. Another example is carbon dioxide, okay? Let's talk about carbon dioxide. Now, carbon and oxygen, both of them want to gain, okay? None of them can give away electrons. And why cannot they give away? We just discussed the periodic table, okay? Because carbon has to gain either 4 or give away 4. So that both of them are expensive things to do. For carbon, cannot do that. Okay, for oxygen, it's easier to gain 2 more, cannot give. So carbon cannot give, oxygen cannot give. So such atoms, when they have to make a molecule in which both of them have to gain electrons, what they do is that they share. They share. Okay, you know, let's share our kids. You know, we can share. My kids would, you know, like go around you, would go around me, and this oxygen's kids. So what's happening? What do I mean by share? What do I mean by share? By share, I mean that these electrons, now I have used this cross for the electrons of carbon and dots for the electrons of oxygen. So dot is an electron of oxygen. So it primarily is oxygen's electron. And this cross is primarily carbon's electron, okay? Now this carbon's electron is revolving around oxygen nucleus as well as its own carbon nucleus. And the oxygen electron is doing the same. It's revolving around oxygen nucleus as well as carbon nucleus. So like they're sort of sharing. Okay, so there's a lot of buzzing around of electrons, and they're buzzing around all these nuclei. So this is what we mean by covalent bonding. Okay, and a simple molecule that is formed in such a way is called a covalent molecule. Okay, Umema, you don't have to write this message again and again. Did you read the chapter before? Or did you listen to my previous classes? Because I cannot expect you to just sit here, listen to what I'm saying and understand automatically, because that's not gonna happen, okay? You have to put in your effort as well for understanding. You're constantly sending me messages that I'm not understanding, okay? Okay, first try your best to understand. If you don't understand, then you come and let me know, okay? Because, you know, there's no magic going on in here. Okay, so you know, this is how they're sharing. Okay, so this is covalent bonding, because, you know, that disturbs me and I forget what I was trying to, you know, what was the point I was trying to make. That disturbs me. Okay, so I hope you guys understood this covalent. So remember, what are these lines that we make? What are these lines that we make? And why don't we make these lines in ionic compounds? Remember, these lines are made only in covalent substances. We make these lines, you know, this style of representing molecules represents covalent substances. These lines represent that the electrons are being shared. Shared is the word here. These lines are representing that the electrons are being shared, okay? Now, how do we represent ionic compounds? Let's talk about them and then compare the two. Ionic is when one atom can completely give away an electron and the other atom can completely accept an electron, okay? Understand this first. Ionic compound is when the metals, now which atoms can completely give away electrons? Remember our periodic table, we understand from 4 sharing starts. From 4 group onwards, sharing starts. So group 1, 2, 3. Forget the transition for now, okay? Don't confuse yourself. 1, 2, 3. These 3 groups can give away, right? So, and they can completely take. They also can completely take. Remember, this was 7. This has 7 electrons because it's in the 7th group. So it needs only 1 more. 7 plus 1, 8. only one more to become stable. These need one more. So they want to give one, they want to take one. So they make very good friends. Group 1 and 7, very good friends, because this throws an electron, this catches it. Hey, I wanted that one electron. And they are, you know, like, who wants one electron? And they say, oh yeah, we want one electron. So they go ahead and make a bond. So how does that happen? This is sodium, same atomic structure, right? 2 in the innermost, and then, you know, 8 in the second shell, and then 8, 9, 10, and then 11. Okay, so the 11th one is in the outermost shell. Fluorine atomic number is 9, so 2 in the innermost, and then 7 in the outermost, and that's why it's in the 7th group, right? And it needs one more. So this electron is lost by sodium. You know, it jumps, and in my diagram, I've shown it jumping from the sodium atom onto the fluorine. So what are we left behind with? A sodium cation. Now, what is cat? What is this cat ion? Now, ion we knew, that's a charged particle. So what is this cat? Cat means positively charged ion. So you can remember it this. You can remember it this way. Cat, positive. So it looks like a positive sign, right? You can remember it this way. Anion is a negatively charged ion. You can remember N for negative, you know, just for your convenience. So N for negative, and this is positive, right? So sodium loses the outermost electron. It becomes the cation, positively charged ion, and this is gaining one electron. So this becomes an anion, negatively charged ion. Now, this has completely lost that electron. That electron is no longer revolving around this nucleus. It has, you know, like it has sacrificed that one electron, absolutely given it away. Okay, this nucleus does not see that electron anymore. And that electron has been completely gained by this nucleus. So this electron revolves around the nucleus of fluorine only now. It does not revolve around the nucleus of sodium anymore. So this is absolutely negatively charged, and this is positively charged. But because they have gained opposite charges, there is attraction between them. And this attraction is what keeps them together. Okay? They don't share electrons, but they are together physically close to each other. Why? Because of the attraction between the positively charged ions. So first of all, the atom loses and the other atom gains. They acquire positively charged. And so the attraction between the opposite charges is what keeps them together. So this is how we get ionic compounds. And we do not use that, you know, that system. We don't use this to represent ionic compounds. We just simply write it this way, simply this way. Okay, sometimes you might see this, but yeah, this is not the standard way of representing ionic compound, because this shows sharing. Okay, they don't share, they're like this, just cation, anion together, that's it. Okay, so now let me show you another example of an ionic compound. So this example that I just gave you was of group 1 and group 7, friendship between group 1 and group 7. Now, what if group 1 wants to be friends with group 6? Then what? But group 1 wants to be friends with group 6. Now, it all depends upon how many electrons this group 1 can give. Now, group 1 can give only one electron because it has only one electron in its outermost shell. And it does not want to disturb its second shell because it wants 8 in its outermost shell. So that's exactly what it has now gotten after losing one electron. So it's not gonna lose more than one. So this is my diagram, okay? So again, 2 in the innermost, 8 in the second, 1 in the outermost, it lost, gave it to oxygen, right? Now remember, oxygen has 6 in its outermost. Why? Because oxygen is in the 6th group. right? Oxygen is in the 6th group. So 6, 7, 8. It needs 2 more electrons, right? So 1 electron it got from this sodium ion. Now, this is not going to give you the second one. Okay, so you got to get it from somewhere else. So, okay, another sodium ion comes in. Okay, I'll give you, I also want to give, I also want to be stable. So can you, take the second one from me? So the second sodium ion gets in and gives away its outermost electron. So now this oxygen is happy because, it got the 8 electrons in its outermost shell. So it's pretty stable. This is also stable, happy, because now it has 8 in its outermost. This is also happy. It has 8 in its outermost. And so all of them are happy. And so this is the end result. So sorry, this was a mistake. So, by mistake, I drew the third shell. So first shell, second shell, 8. First shell, second, 2 electrons, and second shell, 8 electrons. And so positive charge, because they lost 1 electron, positive charge. It gained 2 additional electrons, so -2. So what is the formula? How will we write the formula? Remember, formula is a shorthand writing to represent the number of atoms of each element. So in this particular substance, we have 2 sodiums, 2 sodium atoms. Remember, this small subscript is representing the number of atoms within a particle, within a molecule. So we have 2 sodiums and 1 oxygen. So this is how the formula would be written. Na2O. Na is the symbol for sodium. Okay, did I make sense? I hope I did. Okay, so only 3 minutes are left. And then just real quick, another example, beryllium. Now, beryllium is from the 2nd group. Okay, now I'm showing you how it bonds with group 7. Let's talk about 2nd group elements bonding with group 7. Group 7 needs 1 more. Beryllium is ready to give 2, because by giving away 2, it will be left with only the innermost shell, and for innermost shell, the stable number is 2, okay? So it will lose its 2 electrons to 2 chlorine atoms, because it has to lose 2, and chlorine can have only 1, okay? So each beryllium will lose 2 electrons and will give to each chlorine atom, and so the end result would be this. Chlorine will have gained 1 additional electron. So 2 chlorine atoms with -1 charge and 1 beryllium with +2. So we have 2 chlorine atoms in a beryllium chloride compound and 1 beryllium atom. Sidra, did you understand? Okay. Okay, now I'm open to your questions. Let me check the chat window. Iman Javed, lithium and beryllium are in group 1. No, beryllium is not in group 1. Beryllium is in group 2. Oh, sorry, lithium and beryllium are in group 1 and 2. Okay, so why are they having 3 and 4 electrons? Where are they having 3 and 4 electrons? Aliyan Anwar, teacher, was this all algebra or math? Okay. How can we get periodic table? Google it, you'll get it. There are so many images of periodic table. What is an element? Listen to my previous classes. What is the name of the lesson we did? Do they do the same job? Who does the same job? You will need 2 atoms from G1. Okay. How can the electron orbit both atoms at once? Yeah, okay, that's a good question. How can the electron orbit both the atoms at once? Yeah, they can. And that's what brings the 2 atoms together. I mean, closer together physically. I mean, you cannot picturize the atom. Scientists have still not been able to clearly see an atom. And so these are only educated guesses, okay, computerized pictures. And so, yes, electrons can revolve around 2 nuclei. Can you send the book in our WhatsApp group? I have already sent the PDF of these chapters in my group. Okay, I'll send it again. Maybe you have joined lately And so, okay, double bonds. Okay, we will not talk about double bonds yet. Try to understand the single bonds first. Kalimullah, you don't understand by just, sitting there and listening. You will have to do reading, and you will have to listen to my previous lectures as well. What is nucleus? Okay, it's 8:10, so this is the end of my class. Okay, assalamu alaikum wa rahmatullahi wa barakatuh.